Inverse relations. Every operation in maths, I guess, has an inverse or an opposite. You know, addition has subtraction, multiplication has division. What's the same with relations as well? So inverse relation basically returns the dependent values, that set, back to the independent ones that it came from. So here we go, here's a set where x is going to y, so negative 2 is going to 4, minus 1 is going to 1, and so on. That would be y equals x squared. Now to get those back, so now I want the 1 to go back to, well, either minus 1 or 1, and 4 goes back to either minus 2 or 2. Well, that would be y equals plus or minus the square root of x. Notice we're calling it an inverse relation, not a function. So A and C end up being equal sets. How do you find it? Simply swap the x and the y's around. So we had y equals x squared. If I wanted to find the inverse relation, swap the x and the y's around. So I get x equals y squared. I'll make y the subject of that, and that's where I got the y equals plus or minus the square root of x from. Okay, so what's going to happen with domain and range? Well, they're going to swap as well, because if we're swapping the x and y's around, that means the domain and the range swap around. So the range of the relation will become the domain of the inverse relation, and the other way around as well. So a relation and its inverse relation, if you were to look at both of them on a number plane, they would be reflections of each other in the line y equals x. Now, if I had to draw one of this random graph here, I'll draw in y equals x because I know it's going to end up being a reflection in y equals x. And I want to now plot the important points. So the x-intercepts will become y-intercepts and the y-intercepts will become x-intercepts. Everything's going to swap around. So what I do is I draw, or if you're using a ruler, you just get your ruler, and it's at 90 degrees to y equals x. So I basically slide at 90 degrees. And then the measurement, however far away it is from y equals x, that's where I plot on the other side. So consequently, my x-intercept has become a y-intercept. I could pick another point and another point. There's the two other x-intercepts plotted. Let's do the y-intercept. And then probably those vertices, the two turning points, they're probably good ones to do as well. So let's do those. Whee. And then you basically do as many points as you need to start getting a feel for the shape. So let's plot some in. There we go. If you tilt your head 45 degrees, you'll see, oh yeah, look at that. They are symmetric in the line y equals x. Now, that's inverse relations. We're going to be very interested in inverse functions. So if there exists a one-to-one relationship, that's where it's satisfied both the horizontal line test and the vertical line test, satisfies both. One-to-one relationship. Then both the relation and the inverse relations are functions. That's what we're basically saying. So if you've got that situation, we no longer call it an inverse relation, we call it an inverse function. How do you test? Well, visually, as I say, satisfies both the vertical and the horizontal. That's probably the easiest way. If you've got the picture, you have a look at it, see that it satisfies both tests. If you don't have the picture, swapping the x and the y's around, make y the subject. If you get a unique answer, so there's only one possible answer, then it's okay. It's going to be an inverse function. But if you get ambiguity, so you find yourself saying plus or minus or something like that, then no, it's not going to be an inverse function. So there's the parabola that we talked about before. Visually, yeah, vertical line test, not a problem. It is a function, but no, it fails the horizontal line test. So it won't have an inverse function. It'll just have an inverse relation. So that's if I've got the picture. If I didn't know what that picture looks like, swap the x and the y's around, and like I saw before, I ended up with y equals plus or minus root x. As soon as I find myself saying plus or minus, no good. That's not unique. So it's an inverse relation, not an inverse function. Y equals x cubed, vertical line test, doesn't matter where I put it, yep, satisfies it. Horizontal line test, yep, satisfies it. So this one's okay. It will have an inverse function. Let's do it via algebra. Swap the x and the y's around. So we get x equals y cubed. Well, if I make y the subject, we don't go plus or minus the cube root of x, we just say cube root of x. So there is only one possible answer, so that's good. That is a unique solution, so it has an inverse function. Just a quick one there today.